right, I want to take the integral from 0 to 0.4 of e to the negative x squared minus 1 over x. Right, and it turns out the reason that this is part B of the same question is because e to the negative x squared, that's the series we just found. So I'm going to replace e to the negative x squared with its series. So this is the integral from 0 to 0.4 of 1 minus x squared plus x to the 4th over 2 factorial. And it says I'm going to have to give at least 5 terms. So I'm going to write down at least 5 terms of this series. And actually, I'm going to write down 6 terms because when I subtract the 1, that one's going to go away. Okay. So I'm going to write down 6 terms. So I have plus x to the 4th of 2 factorial minus x to the 6th over 3 factorial plus x to the 8th over 4 factorial minus x to the 10th over 5 factorial. That's 1, 2, 3, 4, 5, 6 terms, so that ought to do it. And then I have to do minus 1. Oh, I should write plus dot 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 minus 1 all over x dx. So this, all of that represents e to the negative x squared. And then all I do is combine my like terms. This isn't anything fancy. I have a 1 and a minus 1, and they cancel. So this becomes the integral from 0 to 0.4. 1 and minus 1 cancel, and I'm just going to have negative x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial plus x to the 8th over 4 factorial minus x to the 10th over 5 factorial plus dot 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 all over x dx. And now every term in the numerator has an x in it. I can divide an x into all of those terms and cancel. So this becomes the integral from 0 to 0.4. Negative x squared over x is negative x. My exponents are just going to get reduced by 1. So I have x cubed over 2 factorial minus x to the 5th over 3 factorial plus x to the 7th over 4 factorial minus x to the 9th over 5 factorial dx. So I'm supposed to take the antiderivative of this, then plug in a 0.4, then plug in a 0, and subtract. So the antiderivative of that polynomial, you just use the power rule. So this will become negative x squared over 2 plus x to the 4th over 4 times 2 factorial minus x to the 6th over 6 times 3 factorial plus x to the 8th over 8 times 4 factorial minus x to the 10th over 10 times 5 factorial. And I have to evaluate that from 0 to 0.4. So I plug in 0.4s. Negative 0.4 squared over 2 plus negative 0.4 to the 4th over 4 times 2 factorial minus negative 0.4 to the 6th over 6 times 3 factorial plus negative 0.4 to the 8th over 8 times 4 factorial minus negative 0.4 to the 10th over 10 times 5 factorial plus dot dot dot. And when I plug in a 0, right, I just get 0. Right, so the fundamental theorem says plug in the 0.4, then plug in the 0. And when I plug in the 0.4, that's it, then I'm done. You could maybe simplify that a little bit, but don't bother. So this is going to be your answer. Okay, so if we wanted to put it in summation notation, I would write the sum. My numerator is always negative 0.4 to a power. Oh, sorry, it's positive. I did something wrong here. I'm just plugging in 0.4s. That just happens to be a negative, so that should be positive, positive, positive. Those are all positive 0.4s. Okay. All right, so I have alternating signs, which means I need a -1 to the n, and I need my first sign to be negative, so I'm going to start n at 1. And then the rest of my terms are all 0.4 to a power over that same power times half of it factorial. Okay, so my powers are even. So this is going to be 2n, and then it's going to be 2n times n factorial. It's from 1 to infinity, because I have the dot, dot, dots here. The question said write down at least the first 5 terms, just because I want it, just to make sure you understood what the terms look like.